Okay, day 2 of missing all that is involved in Science 12.2 and each other. At some point, hopefully, we'll be told we can send you work. And when that happens, this would be the day 2 of the work. So we have questions on page 533, numbers 19 to 22 to go over, because we went over up to 18 in day 1's videos. So number 19 says a step up transformer. Sorry, just need to move it where I can see it. A step-up transformer is connected to a generator that is delivering 125 volts and 95 amps. The ratio of turns of the secondary to the primary is 1,000 to 1. So it's telling us a V is 125 volts, and it's telling us an A is 95 amps. The question is that the primary or the secondary? So read it again. A step-up transformer is connected to a generator. The generator is what's creating the voltage. So, and the generator is delivering 125 volts. That means it's delivering it to the transformer. So that's the primary. And then it says the ratio of the turns on the secondary to the turns on the primary, NS to NP, turns on the secondary to turns on the primary, is 1,000 to 1. So that's the same as saying the NS is 1,000 and the NP is 1. Or maybe the NS is 2,000 and the NP is 2. It really doesn't matter if it's 3,003 or 8,008. The ratio, the lowest common ratio, is 1,000 to 1. And so the question wants to know what's the voltage across the secondary. Well, we know Vs over Vp is equal to Ns over Np. And so we're looking for Vs. So Vp, Ns over Np. Vp is 125 volts, and that's 1,000 over 1. So Vs should be 125,000 volts, which is definitely a step up. Part B says what current flows in the secondary. So now we're looking for Is. And we know Is over Ip is equal to Np over Ns. So Is is going to equal, using the iPad, Ip times Np over Ns. So Is equals Ip, they told us was 95 amps. And now we have to flip the ratio because P's on top, not S for the ends. So 1 over 1,000. So Is is going to be equal to 0.095 amps, or if you want, 95 milliamps. So that's number 19. Number 20. Number 20 says a 150 watt transformer. Okay, so that's my power. And it would be power primary. 150 watt transformer has an input voltage of 9 volts. So Vp is 9 volts. And an output current of 5 amps. Is, 5 amps. What is it, a step up or a step down? So to figure out if it's a step up or a step down, you're going to have to find the Is. So first from this we can get our Ip, because we know power is equal to IV. So I primary will be equal to power primary over voltage primary. So 150 watts over 9 volts. So I primary is that 50 over 3. 50 over 3, so is that 16.6 repeating, I think? 16 2/3 amps. And so now we can find Vs. Vs over Vp is equal to Ip over Is. Remember, for I's, they're flipped. So Vs is equal to Vp IP over Is. Vp was 9 volts. IP was the 16 2/3. It's easier for me to do in my head that way. And Is is 5 amps. What was that? That was like, 150 over 5. It should be 30. So much easier to just go back and look at this than 16 2/3. So V of the secondary is 30. V of the primary was 9. The secondary is bigger. It's a step up. Part B is, what is the ratio of output voltage to input voltage? So they're looking for Vs over Vp. And so it's going to be 30 volts over 9 volts, which reduces to 10 to 3. So the ratio, you can write it either like that as a fraction or like this, but it's 10 to 3. Okay, number 21 says the transformer has an input voltage and current, so V primary is 12 volts and I primary is 3 amps respectively, and an output current, Is, is 0.75 amps. There are 1,200 turns on the secondary, 1,200 turns. How many turns on the primary? So we can go, I would go with the I, so in primary, in secondary will equal I secondary, I primary. Sorry, I was just double checking to make sure I got the numbers in the right spot because you're not here to keep me on the straight and narrow. Is over IP. So in S, 1200, Is 0.75, otherwise known as 3/4. 3/4 of 1200 is 900, divided by 3. In primary should be 300 turns. All right, and the last one. Last one's the tricky one. I'm not sure why number 21 had an arrow beside it, but number 22 has it for a good reason. So number 22 says, Scott, mine at least says Scott, connects a transformer to a 24-volt source and measures 8 volts. So the source, the primary, is 24 volts, and the secondary is 8 volts. So he gets 8 volts out. This, if the primary and secondary are reversed, okay, so the ratio of primary to secondary voltage will give me the ratio of the primary turns to the secondary turns. And that ratio is 24 volts over 8 volts, or 3 over 1. So the number of turns on the primary to the number of turns on the secondary is 3 to 1. So in the question when it says, if the primary and secondary are reversed, they don't say primary watt and secondary watt, and if they were in my class, you know I would say use a noun. They're talking about the primary coils and the secondary coils on the transformer. Remember, the transformer looks like this with the wrappings, right? And then one side is plugged into the AC, which is 24 volts. And then on the other side, you discover you get out 8 volts. Okay, and it's 3 to 1. So I really need 9 on this side if I have 3 on that side. So now when it says it's reversed, it means this whole thing is picked up and switched. So now the ratio of the primary to the secondary is 1 to 3. The primary voltage hasn't changed. It's whatever you're getting, right? So V primary is still 24 volts, and now it's asking what's V secondary. So V secondary over V primary equal to N secondary over N primary, V secondary, V primary, N secondary, N primary. So the primary hasn't changed, primary voltage 24, and it's S over P, so it's 3 over 1 here. Your secondary should be 72 volts. It was decreased by a factor of 3 one way, and now when you switch it, it's increased by a factor of 3. It becomes a step up instead of a step down. Okay? Hopefully that makes sense. So what it means is flip the